How many of you are business leaders, data scientists, or machine learning developers looking to accelerate the machine learning development lifecycle by using a service that allows you to take advantage of advanced machine learning capabilities and also eliminates the undifferentiated tasks like server management? I'm Shelby Eigenbrod, and I'm an AI/ML Specialist Solutions Architect at AWS. For the next 30 minutes, I'm going to walk you through some of the features of Amazon SageMaker that enable our customers to build, train, deploy machine learning models using advanced machine learning capabilities and removing undifferentiated tasks across that machine learning development lifecycle. We have a lot of SageMaker to fit into 30 minutes, so we won't cover every feature inside this session, but we'll start with an overview of Amazon SageMaker, and then we'll dive into some of the features that you can take advantage of across building, training, and deploying machine learning models using Amazon SageMaker. So let's start with a brief overview of Amazon SageMaker. SageMaker is an end-to-end managed service for machine learning that addresses the needs of machine learning builders that they have across each stage of the model development lifecycle, from data preparation to model building to model training and tuning, and finally to model deployment and management. SageMaker is built to provide end-to-end capabilities, but it also supports modular usage in the ability to pick and choose the specific features that you need for your specific use case. For those that are looking for those end-to-end experience and those end-to-end capabilities, though, SageMaker does provide users with an integrated workbench of tools brought together in one place through SageMaker Studio. Let's take a quick look at SageMaker Studio before diving into some of the individual features across these four main categories. Studio provides an integrated workbench sitting on managed infrastructure that spans the stages of the machine learning development lifecycle. And it's built to improve the productivity of data scientists by providing central access and visibility into purpose-built features across all of those stages of the machine learning development lifecycle. And Studio not only provides that central view and the ability to use SageMaker features from a single interface, but it also provides a lot of the visualizations that support each of these features that we'll talk about today. But now let's talk about some of the individual features offered by SageMaker, starting with features related to model building and training. As you can see, there are a lot of features related to data preparation, model building, model training, and model tuning. Unfortunately, we don't have time to go over each of these within this session, but we'll cover a few here. Starting with SageMaker Ground Truth. To build supervised machine learning models, you need labeled data, which can be a heavy lift to create. SageMaker Ground Truth is a fully managed data labeling service that you can easily set up and launch labeling jobs with just a few clicks in the AWS console, or you can also programmatically set up labeling jobs via the AWS SDK. Ground Truth provides over 30 labeling workflows covering computer vision and natural language processing use cases. And the service also includes many ML-driven features, such as assistive labeling of features to increase worker accuracy and efficiency, auto-labeling to reduce the cost of labeling by up to 70%, and annotation consolidation to provide high-fidelity labels. Ground Truth also allows you to use a range of workforce options that suit your needs, whether it's a public workforce, a private workforce, or a vendor workforce. And then finally, there's no lock-in with pay-as-you-go pricing, and you can also qualify for volume discounts as well. So like I mentioned on that previous slide, Ground Truth has built-in workflows for labeling of images, text, videos, video frames, and 3D point clouds. For vision use cases, Ground Truth has built-in labeling workflows specifically for computer vision, including things like image classification, bounding box, semantic segmentation, video labeling, and LiDAR 3D point cloud. For natural language processing, Ground Truth has built-in workflows for text classification, single label, multi-label, as well as named entity recognition. And you can also create custom workflows using 25 custom labeling templates. And custom templates can also even allow you to bring your own custom labeling application to Ground Truth. So now that we've talked about a key SageMaker feature for data labeling, let's talk about another feature from the preparation stage. SageMaker Data Wrangler is a new feature that was announced at re:Invent, and it's aimed at reducing the time it takes to aggregate and prepare data for machine learning. Data prep is a time-consuming and involved process, and we hear from our customers that it takes up to about 80% of the time spent in machine learning development. And data preparation has always been considered tedious and very resource intensive due to the inherent nature of data being dirty and not ready for machine learning in its raw form. Most often, data preparation includes multiple steps, from your data curation, understanding your data, performing your data cleansing, identifying those features that are most likely to have predictive value for your machine learning use case, and then also transforming those features into the format that a machine learning algorithm can understand. Data Wrangler provides all of these capabilities in one place, and it's tightly integrated with other SageMaker features that are key in building out that full machine learning pipeline. Data Wrangler is offered through a central interface directly within SageMaker Studio and offers several key features, starting with, first, the ability to select data from multiple data sources, such as Amazon Athena, Amazon Redshift, AWS Lake Formation, Amazon S3, and Amazon SageMaker Feature Store. You can even write queries for data sources and import data directly into SageMaker from various forms, such as CSV files, Parquet files, or database tables. And that data is then imported into a secure central data preparation environment in Data Wrangler, where users have access to a variety of pre-built tools to prepare their data. To transform your data, once you have it into the platform, Data Wrangler offers a large selection of built-in pre-configured data transforms. So as an example, you can convert a text field into a numerical field with a single click in the platform. You can also do things like rename columns, convert column types, or delete a column. But in addition to those built-in transforms, you also have the ability to author custom transforms as well in PySpark, SQL, or Pandas. Data Wrangler also makes it easy to explore your data through data visualization capabilities. And these visualizations allow you to quickly identify inconsistencies in your data, as well as in your data preparation workflow, as well as even diagnose issues before models are deployed into production. Then finally, Data Wrangler makes it easy to create a pipeline for data preparation tasks because you can export your data preparation workflow to a notebook or to a code script with a single click. This allows you to bring your data preparation workflows into production without manually sifting through hundreds of lines of data preparation code that may be sitting inside of a notebook somewhere. So using SageMaker Data Wrangler, with just a few clicks, you can complete each step of the data preparation workflow, including data selection, cleansing, exploration, and visualization. And all of this is done in a single interface within Amazon SageMaker Studio. So we just covered Data Wrangler as a comprehensive feature within SageMaker for your machine learning data tasks, but let's also cover a core building block that's often used for data preparation workflows. Amazon SageMaker Processing provides managed on-demand compute environments for your data preparation and even your model evaluation tasks. SageMaker Processing provides transient environments with full flexibility in what you choose to run inside those environments, because you can either take advantage of built-in containers for Apache Spark or scikit-learn, or you can also choose to bring your own containers to run a custom environment. So let's take a quick look at how it works. Processing jobs run on a transient cluster that's only active for the time it takes to process the job tasks. So you're only paying for that compute when you need it, and you get to choose your compute in terms of the instance type, which includes both CPU and GPU options, instance size and count, as well as the amount of storage that you want to attach to that instance or instances. Processing jobs expect that data or the input to be in Amazon S3. So for your data preparation task, that input is likely to be your raw data stored in S3. And then again, you select what type of container image to run, whether it's one of those built-in containers or you're going to bring a custom container that you've built. In this case, we see here, we're using our scikit built-in, we're using our Spark built-in container. In addition to the S3 bucket with your input data, as well as the container image, Spark container, that you want to use, you also provide the data processing code that you want to run. And that's what's going to take that raw data on input and then transform it into a format that's expected by your algorithm. Then after the processing job is done and complete, the output gets stored into the S3 bucket that you specify. So in this example, since we're using our processing job for data preparation, we're outputting a training data set and a test data set to S3. Processing is a really powerful way to use a transient compute and storage environment for your data preparation tasks and even your model evaluation tasks. And processing jobs can be used ad hoc, or they can also be used and incorporated into your automated machine learning workflows. So the previous discussion around data wrangler and processing are a natural lead into our next service, which is SageMaker Feature Store. SageMaker Feature Store is another service that was launched at reInvent, and feature engineering can be a heavy lift process with a lot of repetitive feature curation and processing tasks that are required to mainly convert that raw data into training for machine learning algorithms. SageMaker Feature Store was released to reduce that heavy lift and provide fully managed, purpose-built repository to store, update, retrieve, and share features. The feature store can be populated as part of any workflow using the SDK, but it also has built-in integrations with Data Wrangler as well, allowing you to create or update existing features with a single click inside SageMaker Studio. With SageMaker Feature Store, you have the choice of creating an online store, an offline store, or both. An online store is used for low latency real-time inference use cases, and an offline store is used for batch inference or for model building or training activities. You can choose to create both as well, so you can create both an online store and an offline store, in which case SageMaker can automatically replicate your data from that offline or from that online store to that offline store so that they stay in sync. And because the feature store provides the ability to centralize your curated features and store associated metadata so that features can be easily discovered and reused, you can gain efficiencies in avoiding rework and recreating features across teams, as well as avoid inconsistency across features that are used for training and inference. Let's take a quick look at how it works. In a typical workflow, you have your raw data and a feature pipeline that contains the processing code that transforms that raw data into data for model training. You then ingest those curated features into the central feature store, so into SageMaker Feature Store, through either batch or streaming processes. Then those features are made discoverable and shareable for model training and inference. So in the case of model training, it allows multiple teams to use the same curated features for model building. The features are also made available for inference workflows as well. So you can access consistent features and consistent feature data for prediction requests as well. So we talked about several services inside the preparation stage, but let's move on to a few services that support the model building stage, starting with SageMaker Studio notebooks. In the beginning of this session, we talked about SageMaker Studio being an integrated workbench for machine learning tasks that includes SageMaker features that span that machine learning development lifecycle. Studio notebooks are one of the features that are specifically available within Studio, and they are Jupyter-based notebooks that can be launched quickly, and they're hosted on managed compute. That underlying compute that's used for those notebooks is fully elastic, meaning you can easily change the compute that's associated with your notebook without interrupting your work. And you can also share your notebooks with others in just a few clicks as well. Studio notebooks also come pre-configured with many of the popular data science libraries and packages that you'd be looking for, as well as the ability to choose from a number of built-in kernels for Python, but also for frameworks like MXNet, PyTorch, and TensorFlow. Studio and Studio notebooks provide that visual interface for many of our SageMaker features, such as tracking of experiments, as you see here in the screenshot. Then in October of last year, we announced support for Amazon Virtual Private Cloud for SageMaker Studio, which gives you the ability to launch Studio in your VPC to implement those fine-grained controls for network access and internet connectivity for your SageMaker Studio notebooks. One question we get asked frequently as solutions architects is around SageMaker Studio notebooks and our classic notebook instances. And both are available for use, but there are some differences between the two, with the main difference being Studio notebooks are really built and integrated inside SageMaker Studio to provide that seamless integration or the seamless integrated workbench that spans the entire machine learning lifecycle, reaching out into our other SageMaker features. So we've covered one of the environments that you can use to build your models through Studio notebooks inside SageMaker Studio. But another common question we get are, what are the options for training and algorithms for SageMaker? So this brings us to algorithm and framework support for building models in SageMaker. When I talk to customers, there's often a misconception that you have to use a specific set of algorithms or frameworks to build models using SageMaker. So I just wanted to spend some time here to talk about the options that are available for building models on SageMaker, because there really is a lot of flexibility supporting the variety of choice that data scientists and machine learning developers are typically looking for. So with SageMaker, you have 4 key options for training algorithms. First, you can use built-in algorithms provided by Amazon SageMaker. And these algorithms cover a variety of machine learning use cases like clustering, regression, and classification. And many are based on open implementations like XGBoost. If one of these meets your needs, it's a great out-of-the-box solution for quick model training. Second, you can also use a variety of our built-in libraries and frameworks. In this case, you essentially bring your own script and then train your model by pointing to the SageMaker managed container image for that library or framework. In this scenario, we're constantly adding support for new libraries and frameworks, but we currently have managed container images for MXNet, PyTorch, TensorFlow, Chainer, Scikit-learn, and Apache Spark. If the built-in algorithms or built-in frameworks or libraries don't meet your needs, you also have the full flexibility to bring your own Docker container and whatever algorithm or framework that you choose to train, still using the powerful compute and advanced training features of SageMaker. Finally, you can also use an algorithm that you subscribe to from the AWS Marketplace as well. With AWS Marketplace, you can browse and search from hundreds of machine learning algorithms and models in a broad range of categories, such as computer vision, natural language processing, or even use cases like fraud detection or predictive analysis. So with SageMaker, you have full flexibility to use the algorithm, libraries, and frameworks of your choice, which we find is really important to data scientists and machine learning developers. We talked about the flexibility of choice in how you build your models, but what if you're looking for more AutoML capabilities? So this is where SageMaker Autopilot comes in. Amazon SageMaker Autopilot makes machine learning easier and faster. You can build classification and regression models without deep machine learning knowledge. You just provide a tabular data set and you select the target column to predict. And then Amazon SageMaker Autopilot automatically explores machine learning solutions with different combinations of data preprocessors, algorithms, algorithm parameter settings to find that best performing model. So instead of requiring you to decide which algorithm to use, Amazon SageMaker Autopilot basically automatically selects the right algorithm from a list of natively supported algorithms. And then Autopilot also automatically tries different hyperparameter settings for those algorithms to get the best quality model. There's also no need to worry about extensive data cleaning or pre-processing, since SageMaker Autopilot automatically applies different types of data preprocessors to the data before passing it to the algorithms to train the models. Then once Autopilot finds the best performing model, you can then deploy that model to production with just one click or continue to iterate on it. And one of the great things about Autopilot is that you still have full visibility and control into how those models are built. So these aren't black box models. Autopilot generates and provides the underlying code so that you have complete visibility into not only the data exploration tasks, but also the code used for the candidate models in combination with that data transformation code as well. So we talked about some of the SageMaker features in data preparation and model building stages, but let's now talk specifically about features in the model training and tuning stage. Training machine learning models often requires on-demand access to large-scale compute. And SageMaker training jobs allow you to take advantage of on-demand compute resources for model training. And not only do you have access to that large-scale compute, but since training environments are transient, you also only pay for the resources that you need when you need them. Also, to further cost optimize for model training, SageMaker offers managed spot training, which is cool because you can take advantage of AWS excess capacity to save up to 90% off of your model training costs. SageMaker Training also offers several advanced training capabilities, including automatic hyperparameter tuning to find the optimal configuration of hyperparameter values to meet whatever objective metric you're trying to optimize for. You can also use SageMaker Distributed Training, which includes data and model parallelism capabilities to reduce training time for your deep learning algorithms. SageMaker Experiments allows you to track all of your experiments as you iterate on your models to find that best performing model. So with experiments, if you train 23 models and version 16 was the best performing, You can easily track not only the metrics for that model experiment, but also for the inputs and the metadata related to that model. Finally, you can use SageMaker Debugger to debug your training runs in real time. So you're capturing training metrics in real time. With this capability, you can stop a training job early if your model training metrics aren't improving or if your model is already hitting the desired accuracy. And what this does is it allows you to reduce cost and the time it takes to train that model. So training on SageMaker is a popular feature. So let's take a quick look at how it works. First, you can launch a training job for the console or via the Amazon or the AWS Python SDK or the Amazon SageMaker SDK. For training, you load your data into one of three input sources. So it's either Amazon S3, Amazon EFS, or Amazon FSx. You then specify some configuration options for training, such as the training image that you want to use, which is essentially where you specify whether you're using that built-in algorithm, built-in framework, or if you're bringing your own container. Then you can also specify the compute in terms of the type, the size, and the number of training instances that you want to use. And you can, of course, choose between CPU and GPU instances for training. SageMaker then automatically spins up the transient training environment based on that configuration that you provide. And the training environment is only up and running and incurring cost for the time it takes to train your model. Then once that training is complete, your deployable artifact then gets put to an S3 bucket that you specify. And once that model artifact is in the S3 bucket, you can now deploy it to your target environment for consumption. For the purposes of this discussion, we're going to focus on deployment using SageMaker, which leads us to our next section. We're now going to cover SageMaker deployment capabilities. We just went over SageMaker features for the first three stages of data preparation, model building, and model training and tuning. In this final section, we're going to cover some of the SageMaker specific features to model deployment and management. Starting with managed deployment options. SageMaker offers two main categories of managed deployment, including hosting using persistent endpoints or using batch deployments. We'll first cover hosting using a persistent endpoint, which allows you to host your model on managed infrastructure that can be scaled automatically to meet the needs of your workload demands. And it also provides support for those low latency use cases like interactive recommenders or fraud detection. So with a simple configuration via the SDK or a few clicks in the console, you can deploy your trained model to a SageMaker endpoint using a container image for inference and the compute options that you define, such as the instance type, the size, and the number of instances. And you can specify multiple instances to create an endpoint that spans multiple availability zones for high availability and high redundancy. SageMaker will then launch the instances, deploy your model, and set up the secure HTTPS connection that can then be integrated with your consuming client applications. And because these are managed endpoints, SageMaker performs built-in health checks and other routine maintenance, all with built-in support for Amazon CloudWatch metrics and logging. Let's now cover the second deployment option. The second deployment option is batch transform, which essentially means you're sending in batch records for prediction request and getting batch prediction responses back. So with batch transform, you provide your prediction request data set in S3, and then you configure your batch transform job, identifying configuration parameters like the location of the data set, the location of the trained model, and the compute instances that you want to use for that batch job. And then SageMaker takes care of provisioning the resources that are needed, running that batch job, and then putting the batch prediction requests or responses back into the S3 bucket that you specify. And all of this is done in a transient compute environment, meaning batch transform manages all the compute resources that are required to get those prediction responses. And this includes not only launching the instances, but also deleting them after the batch transform job is completed. So with batch transform, it's a great option when you don't need a persistent endpoint that applications can call to get inferences, or you don't need that sub-second latency that Amazon SageMaker hosted endpoints provide. Now that we've covered the two primary options for managed deployment on SageMaker, either using a hosted persistent endpoint or batch transform, let's talk about a few deployment features. Starting with elastic inference. So elastic inference can be used for your persistent endpoints to speed up the throughput and decrease the latency of getting real-time inferences from your deep learning algorithms at a fraction of the cost of using a GPU instance for your endpoint. So with elastic inference, It allows you to add inference acceleration to a CPU-based endpoint or even a SageMaker notebook instance. The next deployment capability that you can take advantage of, and it applies both to batch jobs and persistent SageMaker endpoints, is inference pipeline. Inference pipeline allows you to deploy 2 to 5 containers for sequential execution behind a single endpoint. So you can use this feature to ensure that your pre-processing logic always stays in sync with your trained model, because you're able to reuse the same data transformers that were developed for training for prediction pre-processing as well. As you can see in the picture here, these containers are sequentially executed, and that last container in the pipeline returns the final result to the consuming application. So not only can you include your data pre-processing code, but you can also include things like your post-processing logic to take that prediction response from your model and then format into a consumable response for your client application. And you can host any combination of containers with inference pipeline, built-in algorithm, custom container, making it really extensible to meet the needs of your use case. And all of the containers that are configured as part of your inference pipeline are co-located on that same underlying compute instance so that you can still maintain the low latency on your prediction requests. Another popular feature is the ability to perform A/B testing. So SageMaker has built-in support for A/B testing where you can test 1 to 10 variants or versions of your model behind a single endpoint. And this allows you to roll out new models to production by controlling the amount or which prediction traffic gets sent to specific model versions. So as you can see in this picture here, say we have version 1 of our model and we want to start sending a portion of our traffic to model version 2 to see how model version 2 performs. With SageMaker A/B testing, you can choose to either distribute the request across variants or by invoking a specific variant for that request through the client application. In this example, we're simply specifying that we want traffic distributed for each variant. So in this case, we'll send roughly 66% of our prediction request traffic to model version 1, and then 33% of our prediction traffic to model version 2. And then once you're able to determine how well your new model is performing, you can then replace the old version and start sending all traffic to model version 2, or you can slowly increase the percentage of traffic going to model version 2 and then continue to evaluate. Finally, let's wrap up with one more deployment feature called multi-model endpoints. Multi-model endpoints allow you to deploy multiple trained models to a single endpoint and serve them using a single serving container. You can then easily invoke a specific model by specifying the target model name as a parameter in your prediction request. This feature is ideal when you have a large number of similar models that you can serve through a shared serving container, and you don't need access to all the models at the same time. So for example, if you're trying to predict sales using multiple location-specific models, but none of the models by themselves really consume a large amount of endpoint resources. In this case, one multi-model endpoint can efficiently serve this traffic and enable significant cost savings. So we covered the deployment options as well as some of the built-in deployment features, but what happens once that model is actually deployed? So this brings us to SageMaker Model Monitor. When a model gets deployed, the fun doesn't stop there, right? You need to ensure that you're monitoring your machine learning workloads. And part of that monitoring is monitoring the model for signals of degradation. SageMaker Model Monitor has several capabilities, starting with automatic data collection. So when you create a SageMaker endpoint, you simply enable a feature called data capture, which allows you to automatically capture the prediction request and the prediction response data for either part or all of your endpoint traffic. Then Model Monitor also has a baselining step. So with this baselining step, SageMaker Model Monitor will automatically run analytics against your training data set and use that to create a set of built-in rules to detect drift. You can also modify those rules, or you can even write your own custom rules for custom analysis as well. Then at that point, you set up a monitoring schedule that you define to regularly detect changes in quality or drift on a defined schedule. All of the metrics that are automatically emitted to Amazon CloudWatch, where you can then set up alarms or even trigger downstream automation like model retraining based on signs of drift or decay in your model. Model Monitor can be used through the SDK. However, the visual data analysis feature of Model Monitor is really specific to SageMaker Studio. So this is a quick overview of the types of monitors that SageMaker Model Monitor supports. Depending on the type of monitor, the steps to configure Model Monitor can vary slightly, but For the different types, we have data quality, which detects when your data that's coming in for prediction has drifted from the data that was used to train the model. And then we also have 3 new monitoring types that were introduced at re:Invent, which include model quality, which allows you to see how your model is performing based on new ground truth data that's collected. And then we have bias, drift, and feature attribution, which are part of a new broader service called SageMaker Clarify, which helps you detect bias in machine learning models and also helps you understand your model predictions. We didn't have time to cover Clarify in this session, but definitely an interesting service to check out. So let's wrap up this session by talking about how you tie all of these stages together and all these steps within each stage, which leads us to SageMaker Pipelines. SageMaker Pipelines is another new feature that was launched at re:Invent, and finding a repeatable way to automate and orchestrate all the steps and stages in a machine learning pipeline can be challenging, and it typically involves stitching together multiple services. SageMaker Pipelines was introduced to provide a SageMaker native solution for creating automated machine learning workflows that reduce what can sometimes be a heavy lift in putting together those multiple services and setting up the different integrations to work together across the machine learning pipeline. So there's 3 main components to SageMaker Pipelines, including Pipelines itself, which allows you to create automated model building workflows using the Python SDK. So you're essentially able to create DAGs that can allow you to not only experiment quicker across the iterations of your machine learning development, but also you can use these same model building workflows for your model retraining pipelines as well. And the second component of SageMaker Pipelines is Model Registry, which acts as not only a central store for model metadata, but also includes deployment workflow capabilities where you can use a status approval update to then trigger a downstream deployment, which then brings us to this third component of SageMaker Pipelines, which is projects. Projects allow you to not only automate your workflows, but also incorporate CI/CD practices such as version control, automatic triggers, and quality gates into your machine learning pipelines. And with projects, you can use either built-in MLOps project templates, or you can create and customize your own project templates that can then be used across your teams. Like I mentioned at the beginning, we covered a whole lot of SageMaker in 30 minutes, and there were some features we didn't even touch on. So I definitely recommend checking out some of the resources on this page if you're interested in learning more about SageMaker. Hopefully, with this session, you're able to take away some of the benefits of using Amazon SageMaker for data preparation, model building, model training and tuning, and also the deployment and ongoing management of your models. And finally, you join the AWS Summit to learn, and you can keep the learning going after the summit with resources from AWS Training and Certification. We offer over 65 courses. Many are available free and on demand, as well as virtual instructor-led training as well. For more information, visit the website you see here, and be sure to check out our AWS Ramp-Up Guide to learn more. Thank you so much for joining the session today. And before you go, we really value your feedback. So if you can take a moment to complete the session survey, it's very much appreciated. And thank you again, and I hope you enjoy the rest of your sessions.